maybe some of you might think that would be me getting 100 on the test, right? Probability is 0, right, Ian? Okay. You can also have a probability of 1. It's going to happen. Without a doubt, it is going to happen.
Picking a red card.
That wouldn't be a probability of 1 because it's red and black. Rolling a 6 or less on a die.
That's more like 12%.
Makes sense? Rolling a 6 on a 6-sided die, right? 1, 2, 3, 4, 5, 6. So a probability of 1 is certain rolling a 6 or less on a die. That's a certain. And I want to make this clear. Probability is always between 0 and 1. You can't have a negative probability. You can't have a probability bigger than 1. It always has to be between 0 and 1. Nothing negative, nothing big. You can't have a 200% chance. Okay, it's always between 0 and 1. All good? Make that clear? Yep.
Why is there 100?
There is 1.
Is 1 100?
1 is equal to 100%.
So it could be. So it's decimals in between.
Correct.
Okay.
Or we're going to use fractions.
Okay.
Okay, we're going to stick with fractions and not decimals. Okay? All right, so just basic probability here first, so I know you're on the same page with me here. You got a spinner. It's got 6 equal slices. If you want to draw it, you can draw it, but just pretend you got a spinner, 6 equal slices. What's the probability it lands on a 4? All right, it lands on a 4. Now, I want to start doing some shorthand. Everyone see P4 here? The capital P stands for probability, and what's inside is what I'm looking for. So probability, I spin a 4, because I want to start using some notation now. We're going to always write it as a fraction. It can be expressed as a decimal or a percent, but we're going to do a fraction. So how many different outcomes could there be?
6.
Everyone's good. 6. How many 4s are on there?
1.
So we say the probability is 1 out of 6 chance of spinning a 4. There's only 1 4 out of 6 outcomes. And that is between 1 and 0. All right, that's what I mean between 1 and 0. 1/6 is between 1 and 0. All good there. Basic probability. Before I move on, ask if you don't know. Do not be shy this unit. All right, next one. What's the probability? Same spinner will not land on a 4. What's the probability it will not land on a 4 now? So probability not 4. Capital P stands for probability, a not 4. Still have how many outcomes? 6, right? So it's still out of 6. Now you want to think of how many are not a 4 now, right? 5 out of the 6. Now, some of you, I don't know if you can see that. What I love to do, list them out. List out the possibilities if it helps you. 1, 2, 3, 4, 5, 6. How many are not a 4? 5 of them. Okay, so if it helps to list them out, please do so. Any questions yet? Because now here's where it gets a little hazy. Same spinner. Probability, you get a number greater than 3 and even. Greater than 3 and even. Don't yell anything out here. I just want a probability greater than 3 and even. This is where I like writing them out. Okay, this is where I like writing out all the possible outcomes and counting them up. 1, 2, 3, 4, 5, 6. Still 6 outcomes, right? So out of 6, it's got to be greater than 3 and even. Ready? 1 good?
No.
Nope.
2?
No.
Nope.
Yes.
Wait, why doesn't 2 work? It's even? It's got to be greater than 3. It's got to be both, right? And even. So that's why 2 doesn't work. 3 work? 3 going to work?
No.
Nope. 4? 5? 5 work or no? No, it's got to be even too. 6? Okay, so how many work out of those 6?
2.
And I haven't had to talk about this yet. I will always accept that as an answer, but I would also like you to reduce it if possible. So 2, 6, same as. And if you don't know that, type it in your calculator. Your calculator will reduce it. Everyone try it out right now, please. Type 2 over 6, 2 divided by 6 on your calculator so you can see it being reduced. Everyone see it go down to 1/3. All right, now just so I want to explain myself. Yes, I would accept 2, 6 if you wrote it down. So why do I always have you reduce? If it's a multiple choice question, it probably will be reduced. So I want both answers there for you. All right, multiple choice, you'll probably see a third. All right, let's keep rolling. What about an or now in between? Same question, even, but now I'm putting or greater than 3. Watch what happens. Still how many choices? 6, right? Watch. It's got to be even or, not and, or greater than 3. Can I count 1? Even or greater than 3? No. Can I count 2?
Yes.
Everyone see why I can count 2 now? Because it's even. How about 3? Count 3?
No.
Nope. 4.
Yeah.
Should I count it twice or just once?
Once.
Because it is even and greater. You only can count things once, not twice, right? How about 5?
Yeah.
Can I count 5? It's greater than 3. How about 6? And you only count it once. So how many options do I have now? 1, 2, 3, 4 out of 6. Reduce it. Let's go. Reduce it. I want everything reduced. Just in case it's a multiple choice and 4, 6 is not there, but what will be there will be 2 thirds. Anything you want to ask? I say list them out. That's the best way for me to always do it. List them out. And then start circling, underlining, whatever ones fit. Who, you ready for this one? This one's going to be a little tougher now. Ask questions definitely on this one if you have them. Probability of a number greater than 3 given it's even. All right, First, hold on. We got new notation here. I want to point out new notation. So greater than 3. That should be a vertical line right there, not a slanted one. And even. Make a little note, please. This is the symbol for given right there. Okay, that is the symbol for given, is that vertical line. So greater than 3, given it's even. This ain't going to be out of 6. This ain't going to be out of 6. Why is it not going to be out of 6? Here's why. Ready? We already know something happened. We're given what? What's the probability it's greater than 3 given it's already even? So we don't have 1, 2, 3, 4, 5, 6 anymore. We already know it's even. So what are our only possibilities now? 2, 4, 6. So now I don't have 6 possibilities. I only have 3 possibilities because we already know, right? We already know it's already given it's even. So now out of these 3 possibilities, how many are greater than 3?
2.
That's going to be huge this unit, is these given problems. All right, we already know it's even. So that's why we're not doing 1, 2, 3, 4, 5, 6. We're only doing these even ones. So out of these 3, how many are greater than 3? 2 of them. Make sense? We sure? This is going to be huge, this unit. All right, let's do it. All right, now what are we doing? A coin is flipped and a 6-sided die is rolled. Can we just list off all the combinations first? All right, let's list. I always like to see a list of possible outcomes. So I'm flipping a coin and then rolling a 6-sided die. I'll start out. I could get a 1 and a head.
2 heads.
Here we go.
3 heads.
6 tails.
6-sided, right? Yep. All right, what are my other? That's not it, though.
All of them
With tails.
All of them with tails now, too. I always like to see all the outcomes written, if possible. I'm sorry, 2 tails. Anything else I'm missing?
Nope.
So we know how many, this is maybe all my answers should be out of what?
12.
12, right? Here's 12 possibilities right now. First thing I want you to do is read the notation to me, and I want it written out in words. All right, so what's pH mean? pH, what am I looking for? Probability of heads, yep. All right, I want it written out so you understand what the notation means. And we said there's 12 possible outcomes, right?
Yep.
All right, how many now? Count them out. Take your time. How many involve heads?
6.
6, right? 1, 2, 3, 4, 5, 6 out of 12. You guys know how I roll. I'll accept that I'll accept that Friday, but it might not be a multiple choice answer. So if you don't see 6 12s, what do you see?
1/2.
1/2. All right, I think it's time to start calling on people here. You ready? Go ahead and write out what's number 2 saying here. Let's write out what number 2 is saying. Probability of. Here we go. Now I'm going to make you work. Let's get 13 up here. Let's do this. All right, here we go. What's that saying in that symbol? Probability of. Okay, tails and a 2. And a 2. So both have to happen. All right. So out of the 12 up here, Mariah, how many times does that happen? 2 and a tail.
1 out of 12.
There it is. It's right there. All right, 1 out of 12. Everyone doing all right? Am I going too fast? Much different answer for number 3. What am I asking for 3 now? Felicia, what am I asking for number 3? Or a 2 now. So it could be a tail or a 2, but we don't count anything twice. All right, let's go, Felicia. Out of 12 here, let's see here. I'll go down here and put it. Can I count 1H? No. Nope. 2H. Yep, because it's a 2. 3H. Nope. 4H?
No.
Nope. 5H? 6H. What are you going to tell me about everything here? Because they're all tails. But you are not going to count 2T twice, right? We only count it once. How many do I have up here? 7. Everyone all right? All right, big one here. New one. There's that vertical bar right there. We know what that bar means. So here we go. Probability of, here you go. Take your time on this one. This is where it gets a little nuts here. Where am I going here? Joe, probability of tail. What's that bar mean? What do we write down? Given a what?
2.
Okay. Again, we already know what 2 happened. Am I looking at 12 possibilities now? No. A 2 already happened. Given a 2 has already come up on the spinner. That's it. That's all I got. Those are my only shots. How many choices do I have, Joe, out of those?
5.
Whoa. How many did I just... It's already a 2. How many choices are there that only involve a 2?
2.
So everyone watch my denominator. 2. Only 2 choices. And out of those 2, Joe, how many involve a tail?
1.
That's it. What's up, Nick?
Ceiling.
Everyone all right? It's not out of 12 anymore. It's only out of how many possibilities were given a 2. Questions? All right, let's see if you can do the flip version now. Probability of a 2 given, it's already, the coin came up a tail. I want you to think right now before I call on somebody, how many choices would I have now? Not 12, not 2. It's already a tail. So now how many options do I have? Not 12 options, not 2 options. How many up here show a tail? It's already given a tail here. Max?
6.
6. These right here. Now finish it. Out of these 6, how many contain a 2?
1.
Watch out for the given ones. I guarantee when you're doing a given problem, it won't be out of the total. Anything here? Because here come my favorites. Tables. Love tables. We're going to be doing a lot of tables this unit. Oh, it's not filled in though. Can you help me fill in my table?
No problem.
Yeah, thank you. I appreciate it. Go ahead, fill in my table, please. I'm missing those 3 values. Missing those 3, and I'll ask somebody what you filled it in with. Love tables. All right, not waiting here. Here we go. Filling in the table. Choom, what are we filling in with here? Joe, here we go. What'd you fill in? What do I got over here? Over 5 feet total?
67.
67 looks good to me. How about over 14 years total?
70.
70, and how about total here?
100.
All right, that 100's big because now that's probably going to be my denominator, right? Because I have 100 people here. All right, let's read it and see if we can find it on the chart. What's the probability of the person will be both under 14 and 5 feet tall? Can we find that number in the table? So take your time, look for it right now. If you want to circle it in the table, you can. How many are under 14 and at the same time over 5 feet? Find that number. Over 14 and under 5 feet tall. How many according to the table there? How many according to the table, Felicia? How many? Under 14 and over 5 feet. It is 9, yes? Right here, right? Under 14, over 5. There it is, right at 9. 9 out of what, though? I just don't want 9 because I can't have something bigger than 1. 9 out of? Oh. Out of the total here. We're going out of the total. How many total people here? That's what? Out of 100. That's why that corner box is huge. 9 out of 100. Can I reduce that? Check. I want it always reduced. Can I reduce 9 out of 100?
Nope.
Nope. Okay. Under 14. I choose a person under 14 years old. How many, according to this chart, how many people are under 14 years old? It's just a matter of looking in the right spot. Felicia, you want to get redemption here? How many are under 14? Yep. There you go. Yep. Out of 100 still. Good. And I believe that can be reduced. That's what, 3?
Over 10.
Yep. Reduce it, please, just to get in that habit. Any questions on 1 or 2? Because it gets a little nutty here on 3 and 4. Okay. Over 5 feet, or, please circle that word, or over 14. So they can be over 5 feet or over 14 years old, but something's going to happen here. Ready? Let's start here. Over 5 feet tall, how many do you have?
67.
Over 5 feet tall, you have 67. Along with, how many are over 14 years old?
70.
I think we got a problem, don't we?
Over.
I got 67 people that are over 5 feet but then over 14 years old, you told me 70? How can that be possible? What's the problem going to be?
Counted the 58 twice.
Oh, what's the problem going to be? It's going to be over 100 people.
Yep.
No way. That can happen. Why did that happen? Because watch. Where's the over 5 feet tall?
Counted some people twice.
Look, over 5 feet, over 14 years old. I believe we counted a group twice, didn't we? We did 9 plus 58, and then we did 12 plus 58. What group did we count twice?
58.
The 58 people. So you, when doing an or probability, that's why I had you circle it, you cannot count people twice. So you have to subtract out 58 people that we counted twice. So watch out with the ors. You cannot count people twice. So it actually ends up being, what do I got for that one? 79 out of 100? I don't think that reduces.
Yes, I did. Do you see any of these?
And you're ready for 4. This one's gonna, again, you gotta be on your toes here, because this ain't gonna be out of 100. Why? You choose a person over 5 feet when given, what do we already know?
Over 14.
Yep, underline it, circle it, the givens there. What do we already know? They're already over 14 years old. So it's not out of 100. The only thing I'm looking at is over 14 years old. How many people was that? How many people were over 14?
67.
Oh, how many people were over 14 years old?
70.
So it's only going to be out of those 70, because I already know I got the group of over 14-year-olds, and there's 70 of them. Now only look in that column. Out of those 70, how many are over 5 feet tall?
58.
That's it. You got to watch out for the given ones, because it's not going to be out of the total. It's only out of a certain part. And, whoa, I'm not done yet. 58 out of 70.
29 over 35.
Yep. That's just using your calculator. Ask here. Anything. Go ahead, Leah.
I'm just a bit confused as to why it was 58, not 67.
Okay, because we're looking for, out of these 70 people right here,
Uh-huh.
right, out of these 70, how many are over 5 feet? 58. Okay, so it's just out of these 70, not going this way. Okay, I wasn't going that way.
There's also over 14.
Questions? I love tables. You know what I hate?
Tables.
Pie
Venn
charts.
diagram.
Venn diagrams.
Wow.
I can't stand them. I'll be I don't. They confuse the heck out of me. So if I'm trying to teach it to you and they're confusing the heck out of me, what's that going to mean for you, right?
Confusing.
But you know what I still love?
One doesn't make us great.
No. You know what I still love?
Teaching.
No. Do you know what I still love?
Tables.
Tables. So anytime we see a Venn diagram, you know what we're going to do?
Make it
We're going to make a table out of it, because I love tables and I can teach it better than Venn diagrams. All right, so let's start with our table here. We got mustard and yogurt. Who likes mustard and yogurt, right? That's right. And that's what we're going to do. 2 great things there, right? So let's do mustard. Mustard. That means right in the same, right below it. No mustard, right? They don't like mustard. You either like mustard or you don't. There's only 2 options there. And then we always need a, what did everyone have at the end of our tables? Total, right? Total. So put a total down there. We're good so far?
Let's do 58.
Oh, I'll get there, young buck. I'll get there.
You don't like either.
Relax.
Yeah, you got that.
What's going to go on top?
Yogurt.
Yogurt. No, we're not ready for total yet. Yogurt and no yogurt. So we got yogurt.
Why is yogurt? What the heck?
I could flip them if I want. I don't. What's your deal?
Yogurt.
You like mustard or you don't.
No,
You
yogurt.
like yogurt or you don't.
Yogurt.
Those are my only options.
Yogurt's one higher
Yeah,
than
why is
mustard.
yogurt one higher? Oh.
Because I'm going to fill that in with a number or the people who like both.
I think you're making us more confused.
Oh no, this makes sense now. Yeah, you got it.
No yogurt, and then the total.
Bobby,
This shit right now.
All right, we ready to fill in these numbers? Where's that 22 going?
The top left.
22. No.
Never mind.
No. Where's the 22?
Mustard.
Mustard.
Top right.
No,
Do they like and no yogurt, right? They only like mustard. So I like mustard but not yogurt. 22.
Wait, what? Oh, I got it.
Yeah, you good now?
So the 87.
Well, all right. Where's that 87 going to go? I like yogurt, but I don't like mustard. So
Wait, what? Oh, I get it now.
what about 33 people?
The top left.
They like both because it's in the middle. So I like mustard and yogurt. All right, now let's get to Will's question. What's the deal with the 58?
Neither.
You don't like either of them. So where's that going to go? No mustard, no yogurt. 58? What about the rest? That's on you. Fill it out now. Right? Fill it out. I can't fill out anything for you. You got to fill out the rest. And this is what's great about doing a table. When you do your totals, both totals should be the same. All right, no matter whether you do a column or the total row, it should be the same number at the end. How many total people were in this whole thing then? 200 people, yep. And that, again, that's what I like about doing a table. I don't care if you add them up sideways or up and down. That's wrong. I'm moving over. Total should always be the same going both ways. There it is. All right, ready? Answer a couple questions, and I'm going to let you do your thing on your own. Probability. Start writing in our notation. Likes frozen yogurt, but does not like mustard. So likes yogurt and no mustard. All right, see if you can find where that is on the table because I'm going to call on somebody. Likes yogurt and no mustard. Where is that on the table? And out of how many? Think we got that number? Where is it? Where is it? Ian?
87.
There you right there. Yogurt, no mustard. There's 87 of them. Remember, don't leave the 87 out of how many?
200.
200. Did you check if that could be reduced for me?
Nope.
Cannot be. Yep. Any issues on Ian's answer? B, probability they like mustard. That's it. That's all I wanted, right? The probability they like mustard. Does it matter yogurt? Nope, didn't say that. I just wanted how many like mustard. That's why we have a total column. All right, use your table. How many like mustard according to the table? Have 22 and no yogurt, but there's also another group.
Oh,
Right, just 55. Everyone see that? I'm using the total here. Doesn't matter about yogurt. I just want to know how many like mustard, and 55 of them do out of 200. Does that reduce, Hav? 11 over 40. And then how far have we come here? Given that they like mustard. So this is not going to be out of 200, is it? Because not 200 people like mustard. Given they like mustard. How many people did we just find like mustard?
55.
So it's only going to be out of those 55 people. So look at only that row in your table. Out of those 55, how many like frozen yogurt? Out of those 55, how many like frozen yogurt? 33. And that'll reduce down to watch out for the given ones. List them out if you have to. List them out if you have to. Let's go. Let's get going. And yes, I want your Chromebooks open to the answer key. Everybody, not one person in your group. Everybody. Let's go. I'm going to be all over you guys. We're going right up to the